the power P watts of the wind passing through a wind turbine with radius R meters and a wind speed of S meters per second is given by P is equal to R squared times S raised to the third power all over 2. Calculate the wind speed passing through a turbine with radius 25 meters, producing power of 540 kilowatts. And so we have this equation, P is equal to R squared times S raised to the third power all over 2. And notice that we have P is the power, and that's equal to 540. We have R is the radius, and that's 25. And we have to figure out the wind speed, and that's S. So we have 540 in place of P, and we have 25 in place of R. Next, what we do? We say, what is 25 squared? Well, 25 squared is 25 times 25, and that's going to be equal to 625. And so we have 625 S cubed all over 2, and that's equal to 540. Next, we put 540 over 1, and we cross multiply. Now, when we cross multiply, what do? We take 2, and we multiply it by 540, and we take 1, and we multiply it by 625 S cubed. And so we have 2 times 540, which we have right here, 2 times 540, and we have 1 times 625 S cubed. Again, 1 times 625 S cubed, and that's what we have here. Next, we say, okay, let's multiply. 2 times 540, that gives us 1080. And 1 times 625 S cubed is 625 S cubed. And so in this case, we're gonna switch the equation. And so we have 625 S cubed is equal to 1080. Next, we divide both sides of this equation by 625. And then we cancel. And so when we cancel, we have this 625 cancel with this 625. And we are left with S cubed on the left-hand side. And so we have 1080 divided by 625, and we get 1.728. Next, we take the cube root of both sides. So we take the cube root of S cubed, and we take the cube root of 1.728. And so what happens? When we take the cube root, well, the root and the power cancel out each other. And so we are left with S is equal to the cube root of 1.728, and the cube root of 1.728 is equal to 1.2. So S is equal to 1.2. And that's the answer to this particular question.